We look at our modern world, the sprawling supply chains, instant internet connectivity, brightly illuminated cities, and assume we have arrived as a highly advanced species. But against the cosmic backdrop, our civilization barely registers. The Kardashev Scale measures civilizational progress by a single variable: total energy harnessed. Type 1 harnesses a planet, Type 2 a star, and Type 3 an entire galaxy. Humanity is stuck at the very bottom, using a tiny fraction of Earth's potential. To understand why we've stalled, we have to look at how mass and energy are actually distributed in our solar system. The sun is the undisputed anchor of our neighborhood, accounting for 99.86% of all available mass. Almost everything that exists in this system is locked inside that star. Of the remaining sliver of matter, the vast majority belongs to Jupiter alone. Everything else, including Earth, falls into a miscellaneous category of cosmic dust motes. Our planet intercepts a mere half-billionth of the sun's power output, and of that tiny fraction, we utilize practically none. Ascending as a species means leaving this speck of rock behind. To capture the energy required for true civilizational growth, we have to shift our primary infrastructure away from the planet and toward the star. It seems simpler to keep building solar farms and AI data centers here on the surface, but the physical limits of Earth are surprisingly rigid. 70% of our planet is water, and the polar regions are solar-poor environments, making them unviable for the massive energy capture we need. Much of the remaining land is equally hostile. Building high-density industrial grids in remote, frozen stretches of Siberia is a logistical nightmare. Then there is the thermal ceiling. Exponential AI compute generates immense waste heat. In a thick atmosphere, that heat is destructive and difficult to manage. In the vacuum of space, it can be radiated away indefinitely. Starship is the logistical bridge to the star. Its full and rapid reusability changes the math of spaceflight, making it economically possible to move the millions of tons of hardware required to build an industrial base in orbit. Starship integrates orbit into our global industrial backbone, providing the lift capacity needed to host power-hungry hardware in a dedicated off-world zone. Orbital data centers are minimalist, bare-bones machines engineered strictly for the vacuum. The SpaceX AI-1 satellite is designed for efficiency. It is dominated by massive double-sided radiators and solar arrays, which tower over the central rack of AI compute chips. Each unit handles roughly 150 kilowatts of peak power, using high-speed laser links to beam process data back to the Starlink constellation or directly to the ground. This environment is perfect for computing. The arrays soak up unobstructed solar energy, while the radiators dump waste heat directly into the infinite thermal sink of the void. Scaling this to a civilizational level means packing thousands of these satellites into precise orbital shells. By moving compute off-world, we solve the terrestrial energy crisis and create a decentralized supercomputer that draws its power directly from the source. While a single satellite handles 150 kilowatts, reaching a civilizational terawatt, roughly double the total electrical consumption of the entire United States, requires millions of units. Meeting that demand requires an industrial output unlike anything on Earth today. This is the purpose of the Terafab, a 100 million square foot facility dedicated to producing 1 billion AI chips every year. At 10 times the size of a standard gigafactory, it is the only way to manufacture the sheer volume of hardware required. But even with Starship, launching millions of tons out of Earth's deep gravity well becomes inefficient. The final phase of the plan moves production to the moon. With no atmosphere and only 1/6 of Earth's gravity, the moon is the perfect industrial launch pad. Instead of chemical rockets, we use an electromagnetic mass driver. This railgun shoots lunar-manufactured solar arrays and AI chips directly into deep space. This constant stream of hardware provides the components for a massive energy-harvesting constellation surrounding our sun. The SpaceX master plan establishes the industrial foundation for a Dyson swarm, providing the energy necessary to transition toward a Type 2 civilization.